Welcome back. I'm glad you've returned to the silence. We leave the familiar behind to witness the silent beauty of the cosmos as we begin our long, drifting journey toward the Oort Cloud, the immense and mysterious sphere of comets that marks the outermost frontier of our solar system. Beyond the warm embrace of the rocky inner planets, past the gas giants and the icy plains of Pluto, lies a realm of absolute serenity. It is here, at the very edge of the sun's gravitational dominion, that a vast and ancient structure holds the secrets of our cosmic dawn. We are traveling to a place where time seems to stand completely still, a colossal shell of icy fragments that envelops everything we have ever known. To comprehend this distant region, we must imagine a space so vast that distance itself loses its everyday meaning. This cosmic boundary is not a flat ring like the asteroid belt, but a magnificent, all-encompassing sphere that wraps around the solar system in every possible direction. Out here, the sun is no longer a bright, warming disk, but rather an exceptionally brilliant star, cast against an ocean of velvet blackness. The light from our home star takes nearly a year to reach the inner edges of this domain, traveling through the void to illuminate frozen worlds that have remained untouched for eons. In this profound cold, temperatures hover just above the absolute baseline of the universe, preserving the primordial ingredients of creation in a permanent state of deep freeze. What forces could have created such a colossal structure at the absolute edge of interstellar space? Scientists believe these trillions of icy bodies were actually born much closer to the sun, during the chaotic infancy of our planetary neighborhood. As the giant worlds like Jupiter and Saturn grew, their immense gravitational fields acted as cosmic slingshots, hurling these leftover building blocks far out into the dark abyss. Over billions of years, the gentle, collective gravity of the Milky Way galaxy slowed these escaping fragments, molding them into the stable, spherical cloud that exists today. It is a beautiful irony that these objects, born in the fiery heart of our early solar system, now serve as its silent, frozen sentinels. In this quiet expanse, the concept of motion transforms into something deeply meditative and slow. The icy mountains of the Oort Cloud travel along orbits so immense that a single journey around the sun can take millions of Earth years. Their movement is a delicate dance, balanced on a tightrope between the fading pull of our sun and the mysterious gravitational tides of the wider galaxy. The slightest disturbance, perhaps the distant passage of a neighboring star system, can break this fragile equilibrium and change the course of an icy body forever. When this happens, a solitary traveler begins a long, lonely descent toward the inner solar system, transforming from a dark, frozen rock into a spectacular comet with a glowing tail of gas and dust. As we drift deeper into this poetic boundary, we realize that the solar system does not end abruptly, but rather fades gracefully into the grand cosmic ocean. This icy sphere is the true bridge between our local star and the vast, uncharted territory of interstellar space. It reminds us that we are part of a deeply connected universe, where even the most distant, invisible frontiers hold the keys to our own origins. Let your mind drift through this peaceful, silent realm, surrounded by trillions of sleeping comets, as we prepare to explore the profound wonders of this majestic gravitational boundary. We begin our deep contemplation of this outer realm by honoring the human minds that first perceived its existence through the lens of mathematics and observation. In the middle of the 20th century, a visionary Dutch astronomer named Jan Oort looked closely at the strange paths of comets entering our inner skies and realized they must originate from a vast, unseen reservoir. He noticed that these icy visitors arrived from all possible directions, suggesting that their home was not a flat disk, but a giant, protective sphere enclosing our stellar system. Decades before him, an Estonian astronomer named Ernst Oppik had also pondered a similar concept, laying the early foundations for this grand cosmic theory. Today, we call this magnificent boundary the Oort Cloud, a tribute to the human curiosity that maps the invisible long before our machines can ever touch it. How beautiful it is that our minds can reach across trillions of miles of darkness to discover a sanctuary of ice just by watching the dance of falling stars. Even with our most advanced instruments and telescopes floating in the silent void of space, this cosmic sphere remains entirely hidden from direct human sight. It is a theoretical world, a masterpiece of astrophysics that we know must exist because of the gravitational clues left behind by its icy inhabitants. Because these tiny worlds are so incredibly far away and reflect absolutely no sunlight, they slip quietly through the dark, invisible to our most powerful cameras. We verify this magnificent shell not by looking at it directly, but by studying the long-period comets that occasionally break free from its frozen grip and journey past Earth. It reminds us that some of the greatest structures in the universe do not announce themselves with brilliant light, but prefer to remain cloaked in the soft, dark velvet of interstellar space. We must learn to trust the silent language of mathematics and gravity to understand a place that our eyes cannot yet behold. To truly appreciate the scale of our isolation, we must measure the immense gulf of space that separates us from the inner boundary of this icy kingdom. This silent frontier begins at a distance of roughly 2,000 astronomical units from the warm, life-giving light of our sun. To cross this vast expanse would require traveling 2,000 times the distance between the Earth and the Sun, a journey that exposes the profound emptiness of our cosmic neighborhood. Even our fastest robotic explorers, traveling at tens of thousands of miles per hour, will require thousands of years just to cross the threshold into this quiet domain. At this immense distance, the sun is no longer a bright, welcoming face, but rather a solitary point of piercing white light, unable to melt the ancient frost of these forgotten worlds. Here, the solar system begins to shed its planetary identity, transitioning into an endless ocean of quiet potential. This massive distance creates a natural buffer zone, separating our bustling planetary family from the deep silence of the rest of the galaxy. If the inner boundary of this realm leaves us breathless, the outer limits of the sphere stretch our imagination to the absolute breaking point. The edge of this magnificent structure extends outward to a staggering distance of 100,000 and perhaps even 200,000 astronomical units from our home star. This means the outermost icy sentinels are drifting nearly halfway to our nearest stellar neighbor, Alpha Centauri, touching the very edge of interstellar space. At this unbelievable distance, the gravitational grip of our Sun becomes so weak that it is almost equaled by the collective pull of the surrounding galaxy. These outer bodies exist in a state of delicate suspension, caught in a perpetual cosmic tug-of-war between our home star and the wider Milky Way. It is a place where the concept of a solar system finally dissolves, blending softly into the grand, interconnected tapestry of the galaxy itself. This immense scale reveals that our star holds sway over a territory far greater than anyone could ever perceive by just looking at the planets. To ground our minds in these staggering distances, let us contemplate the meaning of the astronomical unit, the cosmic yardstick we use to measure this outer darkness. A single astronomical unit represents the average distance from the center of our Earth to the center of our bright, nurturing Sun, a journey of roughly 93 million miles. Light itself, the fastest entity in the cosmos, requires more than 8 minutes to cross this single unit of celestial space. Now, let your mind expand as you realize that the outer shell of this comet reservoir lies more than 100,000 times further out than that fundamental distance. A beam of sunlight, which rushes past our planet in mere minutes, must travel for more than a year and a half just to reach the outermost edges of this icy cloud. This vast scale humbles our perception of time and space, revealing that our planetary home is merely a tiny spark at the center of an unimaginably grand dark hall. As we explore this silent architecture, we discover that the comet cloud is divided into two distinct, harmonized structures that work together as a cosmic sanctuary. The inner portion of this domain is shaped like a thick, heavy donut or torus, known to astronomers as the Hills Cloud. This inner ring serves as a dense and massive reservoir, containing a vast majority of the icy bodies that sleep in this distant space. Beyond this heavy inner ring, the structure expands into a beautifully perfect outer spherical shell that completely surrounds our solar system in all 3 dimensions. This outer sphere is the source of the long-period comets that occasionally grace our night skies with their long, glowing tails. Together, these 2 regions form a complex and elegant system of cosmic preservation, protecting the ancient icy heritage of our stellar neighborhood. The interplay between these 2 shapes creates a beautifully balanced cosmic layout that has endured for billions of years. The total volume of space occupied by this giant sphere is so immense that it defies any comparison to the objects we know on Earth. It represents a colossal 3-dimensional bubble of darkness that easily swallows the orbits of all the planets, asteroids, and Kuiper belt objects combined. If we were to view our solar system from a distant star, the giant worlds like Jupiter and the tiny world of Earth would be completely invisible, lost at the very center of this massive sphere of ice. It is by far the largest single structure associated with our sun, occupying a domain of space that dwarfs the planetary realm by millions of times. This enormous volume highlights the beautiful asymmetry of our cosmic home, where the worlds of rock and gas are concentrated in a tiny central point, surrounded by an ocean of quiet, frozen potentiality. We are drifting through a cathedral of space, so wide that a human life is but a silent blink within its walls. The vastness of this volume ensures that the solar system possesses a grand, protective buffer against the empty wilderness of the interstellar void. Despite the staggering number of icy objects that sleep within this cosmic sphere, the space they inhabit is defined not by crowded chaos, but by absolute, breathtaking emptiness. Trillions of icy mountains drift through this immense volume, yet they are separated from one another by distances of hundreds of millions, or even billions, of miles. If you were to stand on the surface of one of these lonely comets, the next closest icy world would be completely invisible to your eyes, lost in the deep, dark void. There are no dramatic collisions or crowded fields of debris here. Instead, there is only a serene and timeless isolation. The cloud is a whisper rather than a roar, a sparse collection of lonely travelers who never meet, each tracing its own solitary path through the dark. This absolute spaciousness brings a profound sense of peace, reminding us that the universe is built upon a foundation of quiet, uncluttered stillness. When we consider the collective weight of these trillions of icy travelers, we encounter another fascinating paradox of astrophysics and cosmic scale. Despite its gargantuan size and the unbelievable number of individual objects it holds, the total mass of this grand sphere is surprisingly small. Scientists estimate that if we were to gather every single piece of ice and rock within the cloud and melt them together, they would weigh only a few times the mass of our Earth. Because these objects are made primarily of water ice, methane, and ammonia, they are light and porous, floating like frozen dust motes in a vast, dark ballroom. This reveals that the outer frontier of our solar system is not a heavy, dense wall, but a delicate, ethereal web of frozen moisture. It is a comforting thought that such a massive and influential cosmic structure is composed of materials as gentle and familiar as winter snow. This lightness of mass proves that the majesty of the universe is often expressed through dispersion and grace rather than heavy density. The frozen worlds that inhabit this dark boundary are not recent additions to our universe, but are instead the pristine, unaltered ancestors of our planetary family. They were born more than 4,500,000,000 years ago, during the very same turbulent era when the Sun and Earth first coalesced from a cloud of gas and dust. While the planets have changed over billions of years through heat, volcanoes, and weather, these distant icy bodies have remained perfectly preserved in the absolute zero of space. They are cosmic time capsules, holding the untouched chemical ingredients that originally built our oceans and perhaps even triggered the spark of life. To study them is to look directly into the past, touching the raw, ancient material from which everything we know was created. As we drift among these sleeping elders, we are surrounded by the deep, undisturbed memory of our cosmic origins, resting quietly in the dark. This preservation of ancient history makes the comet sphere the ultimate library of our stellar system, waiting silently at the edge of the world. As we deepen our gaze into the heart of these distant travelers, we find that their physical essence is defined by the most fundamental element of cosmic life, which is frozen water. These pristine objects are not hard, metallic boulders like the asteroids close to the sun, but are instead beautiful, fragile spheres of primitive ice. This water has been frozen solid for billions of years, remaining completely unchanged since the birth of our stellar neighborhood. It exists in an amorphous state, meaning its molecular structure is disorganized and loose, lacking the crystalline patterns found in terrestrial snow. This soft, porous arrangement allows the ice to trap other ancient gases within its deep, silent pockets, serving as a pristine vault for the building blocks of creation. When we look at these distant mountains of frost, we are looking at the very same water that would later fill the vast oceans of our home planet. Interwoven with this ancient water ice are significant amounts of frozen carbon monoxide and carbon dioxide, compounds that would instantly vaporize in the warmth of the inner planets. In the deep freeze of the outer shell, these volatile gases are forced into a permanent, rock-hard solid state that helps bind the icy matrix together. These substances are highly sensitive to the faintest hint of heat, which explains why they react so dramatically when they finally begin their rare journeys toward our sun. Because these carbon-based ices have been kept in total darkness for eons, they preserve the exact chemical signature of the primordial cloud that preceded our solar system. Scientists study the behavior of these frozen gases to understand the ancient environment where the giant planets first gathered their mass. They remind us that even the air we breathe has deep, frozen roots stretching out to the very edge of the gravitational frontier. Beyond the carbon compounds, the icy bodies of this distant reservoir are enriched with frozen methane and ammonia, adding layers of rich chemical complexity to their silent structures. These ingredients exist as a soft, ghostly frost, coating the surfaces and infusing the interiors of the wandering mountains. Methane, which exists as a simple gas on Earth, becomes a quiet, frozen solid in this dark kingdom, locked away in a timeless slumber. Ammonia plays a vital role by lowering the freezing point of mixtures, creating fascinating chemical dynamics that scientists are only beginning to comprehend through mathematical models. These elements are highly reactive when exposed to energy, representing a vast reservoir of organic potential waiting quietly at the edge of space. The presence of these specific compounds confirms that the outer boundary is a rich storehouse of cosmic chemistry, holding the raw ingredients that can trigger the emergence of complex planetary systems. Although we often imagine these comets as bright white snowballs, their outward appearance is actually masked by a deep, velvety crust of midnight black. For billions of years, these objects have been exposed to a relentless rain of high-energy cosmic rays originating from distant exploding stars across the galaxy. This constant, invisible bombardment breaks apart the simple molecules of methane and ammonia on the surface, reorganizing them into complex, dark organic polymers known as tholins. This process creates a thin, insulating blanket of dark matter that absorbs what little starlight falls upon these lonely travelers. This dark crust acts as a protective shield, preserving the pristine, volatile ices hidden safely beneath the surface from any sudden changes in energy. It is an extraordinary paradox that these objects, which create the most brilliant, glowing tails in the night sky, spend most of their lives cloaked in the darkest shades of the cosmic ocean. The environmental conditions within this grand sphere are governed by an intensity of cold that is almost impossible to recreate within our warmest imagination. Temperatures in this outer wilderness hover consistently around 3 Kelvin, which is just a few tiny degrees above absolute zero, the theoretical point where all molecular motion ceases. At this profound baseline of temperature, there is no heat to agitate the atoms, causing time itself to feel functionally suspended within the ice. The only warmth comes from the faint, collective glow of the entire Milky Way galaxy and the ancient cosmic microwave background left over from the birth of the universe. This extreme cold ensures that the chemical reactions that typically alter matter are completely frozen in place, locking the objects in a state of perfect preservation. It is a sanctuary of absolute thermal stillness, where the universe protects its most fragile memories from the destructive forces of heat and energy. Because of their dark, carbon-rich crusts and the absence of nearby light, these icy travelers possess an exceptionally low albedo, meaning they reflect almost no illumination. If you were to shine a flashlight on one of these objects, it would appear as dark as fresh asphalt or charcoal, swallowing the light rather than scattering it into the void. This incredible darkness is the primary reason why these trillions of objects remain entirely invisible to our modern telescopes, hiding perfectly against the black backdrop of space. They are masters of disguise, drifting through the dark hall without leaving any visual trace of their epic, slow journeys. This characteristic forces astronomers to rely on rare stellar occultations, where a hidden comet briefly blocks the light of a distant star, revealing its silent presence. This low reflectivity reminds us that the universe is filled with massive, hidden realities that choose not to reflect the light, demanding that we develop deeper ways of seeing. When we examine the structure of these frozen travelers more closely, we discover that they are not purely made of ice, but are instead a delicate mixture of frost and primitive cosmic dust. Embedded deep within the icy matrix are microscopic grains of silicate minerals, metals, and carbon-rich dust particles, resembling dark grains of sand trapped inside a winter glacier. These tiny dust particles are the literal ash of ancient stars that died long before our sun was even born, scattered into the void and gathered by gravity. As the ice gently binds these grains together, it creates a structural network that gives the comet its physical integrity, preventing it from simply dissipating into space. This combination of volatile ice and solid dust has led scientists to describe these objects as dirty snowballs. Though they are perhaps better understood as beautiful, icy tapestries woven from the dust of forgotten stars. This delicate balance of materials ensures that each comet carries a physical record of both the volatile gases and the solid debris of our solar system's earliest days. In this frozen domain, the familiar phases of matter that we experience on our warm Earth are completely redefined by the absence of atmospheric pressure and heat. Liquid water, which is the fluid foundation of terrestrial life, cannot exist under any circumstances in this vast, open void. Here, water ice does not melt into a liquid when exposed to energy. Instead, it undergoes a direct transformation called sublimation, turning straight from a solid ice into a ghostly gas. However, because there is virtually no energy to trigger this change out here, the ice behaves exactly like solid rock, maintaining its shape and structure over billions of years. Mountains of ice stand as firm and unyielding as granite cliffs, completely unaffected by the flowing currents or erosion that reshape our home planet. This absolute solidity reinforces the timeless nature of the outer cloud, where the fluid transitions of life are replaced by the permanent architecture of ice. The scale of the individual objects drifting through this grand sphere varies dramatically, creating a diverse population of hidden worlds that spans a massive spectrum of sizes. The vast majority of these icy travelers are relatively small, ranging from tiny, pebble-sized grains of frost to icy boulders the size of a house. Yet among these countless smaller fragments drift millions of massive icy mountains, measuring anywhere from 1 to tens of miles in diameter. These larger bodies possess enough mass to exert their own faint, whisper-thin gravity, though it is far too weak to pull them into perfect spheres. They remain irregular, jagged fragments, shaped by the ancient collisions and disruptions of the early solar system's chaotic youth. This wide distribution of sizes reveals that the cloud is not uniform, but is instead a complex ecosystem of debris, where every size of frozen matter finds a place to rest. As we reach the outer limits of our understanding, astrophysics suggests that the deepest shadows of this comet sphere may hold even greater secrets hidden among the small fragments. Mathematical models indicate that a significant number of large, dwarf planet-sized objects, similar in scale to Pluto or Sedna, may be drifting silently in this distant dark. These massive worlds would possess enough gravitational power to clear small pathways through the surrounding ice, acting as hidden kings of the outer frontier. Because they reside so far beyond the reach of our current observation, they remain entirely undiscovered, tracing their immense orbits in complete and total isolation. The existence of these hidden worlds challenges our definition of the solar system, reminding us that there are likely entire planetary bodies that humans have never seen. They sit as silent, icy monuments to the sheer scale of our star's dominion, waiting in the deep darkness for a future generation to finally map their cold surfaces. The movement of these icy travelers is defined by paths that are incredibly elongated, forming extreme ellipses rather than the neat, predictable circles of the familiar planets. These orbits are stretched out like long, thin ribbons across the dark expanse of space, connecting the hidden outer chill with the warm heart of our stellar system. A comet spending eons in the outer cloud will experience a radical change in its path if it is nudged toward the sun, diving deep into the inner planetary neighborhood before returning to its distant home. This dramatic shape means that for nearly their entire existence, these objects remain suspended at the farthest edges of their journeys, barely moving against the background of stars. It is a striking contrast to the stable tracks of Earth or Mars, showing how the outer universe embraces a more fluid and dramatic geometry. This stretched-out movement creates a beautiful rhythm, where a lifetime of slow drifting is answered by a brief, fiery rush through the light. Because these paths are so immense, the time required to complete a single trip around the sun is measured in millions of Earth years. A solitary icy world might have started its last journey toward our star when dinosaurs still walked the Earth, drifting silently through the dark, while entire species rose and fell in the warmth below. This slow cosmic clock operates on a scale that humbles human history, turning a single orbital year into a grand epoch of time. Out here, the frantic pace of planetary life fades into a deep, rhythmic patience where centuries pass like brief, unrecorded moments. When we look at a comet in our night sky, we are witnessing a traveler that has been falling through the void for millions of winters just to spend a few brief weeks in our light. It is a quiet reminder that our local time is merely a rapid whisper inside a universe that thinks in grand, ancient cycles. The stability of this vast comet sphere is constantly influenced by the subtle, collective gravitational pull of the entire Milky Way galaxy. Known to astronomers as galactic tides, this gentle force arises from the combined mass of the billions of stars and massive clouds of gas that form the galactic disk and core. Even though the center of the galaxy is unimaginably distant, its shifting gravity acts like a soft ocean tide, squeezing and stretching the outer edges of the comet cloud over vast periods of time. This interaction constantly reshapes the orbits of the farthest icy bodies, nudging some into the inner solar system and pulling others away entirely. It reminds us that our solar system is not an isolated island, but is deeply connected to the grand, breathing rhythm of the wider stellar ocean. This galactic influence proves that even at the edge of our sun's territory, the grander universe is always speaking to us. Every few million years, the quiet serenity of this outer domain is gently disturbed by the close passage of a neighboring star traveling through our galactic neighborhood. As these stellar visitors drift past the outer boundary, their massive gravitational fields act like invisible rakes, disrupting the delicate paths of thousands of sleeping comets. This cosmic encounter can trigger a sudden shower of comets, sending a wave of icy travelers descending toward the inner planets over the course of millennia. Scientists track these historical stellar flybys to understand the periodic arrivals of spectacular comets that have graced Earth's night skies throughout ancient history. These encounters reveal that the boundaries between stars are porous and interactive, creating a beautiful exchange of gravitational whispers across the deep void. We are reminded that our sun is merely one traveler among many, constantly brushing shoulders with the family of stars. In its long, orbital journey around the center of the galaxy, our solar system occasionally passes near massive structures called giant molecular clouds, which are dense nurseries where new stars are born. The immense gravitational mass of these cosmic clouds exerts a powerful pull on the outer reaches of our comet sanctuary, causing significant shifts in its delicate architecture. This interstellar encounter can strip away thousands of icy objects from the outermost layer, scattering them into the deep space between stars to wander as rogue comets. At the same time, it can compress the inner regions, destabilizing orbits and sending new visitors on a path toward the sun. These grand interactions demonstrate how the larger structures of the cosmos constantly sculpt the smaller, fragile remnants of our local planetary family. It shows that our boundary is elastic, shaped by the massive forces that govern the birth and death of stars. To understand the extreme journeys of these objects, we must contemplate the concept of aphelion, which is the specific point in an orbit that lies farthest from the sun. For the inhabitants of this distant sphere, their aphelion represents a place of supreme isolation, situated hundreds of billions of miles away in the absolute darkness. At this apex of their path, the sun's gravitational hold is reduced to a faint whisper, barely strong enough to turn the object around and pull it back home. The comet may spend hundreds of thousands of years lingering at this distant turning point, moving so slowly that it appears to be completely stationary in the interstellar void. It is a place of profound balance, where the forward momentum of the object finally yields to the eternal, patient pull of its parent star. This turning point represents the absolute limit of our solar system's physical reach, a quiet boundary where gravity pauses before changing direction. At the farthest point of these incredibly elongated paths, the speed of these icy travelers drops to an absolute crawl that is surprisingly familiar to human experience. While planets like Earth rush through space at thousands of miles per hour, a comet at the edge of the cloud might move at only a few miles per hour, a speed comparable to a gentle walk or a drifting sailboat. This slow motion creates a landscape of absolute tranquility, where change occurs over vast, geological timescales rather than minutes or hours. The energy of the object is almost entirely stored as gravitational potential, waiting patiently to be converted back into blinding speed as it eventually begins its long fall back toward the sun. This peaceful, slow movement reinforces the meditative quality of the outer frontier, where the frantic rush of the universe is tamed into a soft, steady drift. It is a realm where speed is forgotten, and the beauty of motion is expressed through absolute stillness. Unlike the familiar planets, which all travel within a flat, neat disk called the ecliptic plane, the comets of this outer reservoir move along paths that are tilted at every imaginable angle. Their orbits can be completely perpendicular to the planetary disk, approaching the inner solar system from directly above or directly below the north and south poles of the sun. This chaotic distribution of angles is what gives the outer cloud its perfectly spherical shape, creating a complete shell of ice rather than a flat ring. When a long-period comet arrives in our skies, astronomers must look in all directions, as these visitors can appear suddenly in constellations where planets are never seen. This three-dimensional freedom highlights the grand transitions of scale, where the flat geometry of the inner worlds gives way to the total embrace of a cosmic sphere. It shows that the true shape of our home is not a wheel, but a magnificent bubble of dark potential. Because the outer edges of this domain are so loosely bound to our sun, a significant portion of its icy population is constantly escaping into the interstellar void, lost to our solar system forever. A minor gravitational nudge from a passing star or a galactic tide can give an object just enough energy to break its ancestral bonds completely. Once free, these lonely fragments become true cosmic nomads, wandering the empty space between stars without a home or a sun to light their way. It is estimated that billions of comets have been shed into the galactic ocean over the lifetime of our solar system, contributing to a vast population of interstellar debris. This continuous loss reveals that our comet sphere is a leaking vessel, slowly sharing its ancient history with the wider universe through the quiet mechanics of gravity. These escaping travelers remind us that the boundaries of our home are fluid, always open to the vast infinity beyond. To maintain this magnificent spherical structure over billions of years, despite constant losses, the universe relies on a beautiful system of internal replenishment. The inner portion of the cloud, that dense, donut-shaped reservoir known as the Hills Cloud, acts as a permanent supply room for the outer sphere. When the outer shell loses comets to interstellar space or sends them diving toward the sun, the gravity of the inner reservoir slowly pushes new icy bodies outward to fill the empty spaces. This continuous, slow migration ensures that the protective sphere remains intact, preserving its grand architecture across the eons. This harmonious exchange between the inner ring and the outer shell represents a masterclass in cosmic balance, allowing a fragile structure of ice to endure for nearly 5 billion years. It reveals an interconnected network of matter, where the deep interior constantly sustains the outermost frontiers of our dark home. To appreciate the profound history of this outer sanctuary, we must understand how it differs from the closer icy ring known as the Kuiper Belt. While the Kuiper Belt is a relatively flat, ordered disk extending just beyond Neptune, the comet sphere is a completely all-encompassing bubble that dwarfs it in every metric. The objects in the closer belt still follow the general plane of the planets, moving in neat, circular tracks that mirror the inner world. In stark contrast, our distant sphere breaks free from this structural flatness, representing a transition into a truly three-dimensional cosmic environment. Understanding this geographical boundary allows us to see how our solar system evolves from a structured cosmic wheel into a beautifully symmetric sphere of dark potential. It is the definitive line where the organized geometry of planetary orbits dissolves into the infinite architecture of the galactic wilderness. The true origin of these icy fragments is rooted not in the dark outer abyss, but in the vibrant, chaotic birthplace of the giant planets themselves. Billions of years ago, the region now occupied by Jupiter, Saturn, Uranus, and Neptune was filled with a dense disk of primitive icy rocks called planetesimals. These small objects were the raw building blocks that failed to combine into larger worlds, remaining as fragile remnants of the early solar nebula. As the gas giants grew in mass and migrated through space, their immense gravity began to disrupt this crowded planetary nursery. The small icy bodies were caught in a violent celestial lottery, subjected to intense gravitational interactions that would forever alter their destinies. It is a profound realization that the loneliest inhabitants of the outer frontier were actually born in the crowded, energetic heart of our young solar system. The mechanism that transported these objects across billions of miles of darkness was a series of massive gravitational slingshots executed by the giant worlds. when a small, icy planetesimal drifted too close to a massive planet like Jupiter. The planet's immense orbital energy was transferred to the tiny object. This encounter accelerated the fragile rock to incredible speeds, launching it on a wild, outward trajectory away from the sun. Many of these objects were thrown with such violence that they escaped the solar system entirely, becoming lost to the interstellar void. However, a specific fraction of these scattered travelers was thrown just far enough to reach the outer limits without completely breaking free from the sun's fading grip. This energetic sorting process highlights how the grand architecture of the outer cloud was sculpted by the raw power of planetary dynamics. As these scattered icy mountains reached the outer limits of their violent journeys, a separate cosmic force intervened to shape them into a stable sphere. During its infancy, our sun was not a solitary star, but was born inside a crowded stellar nursery surrounded by hundreds of sibling stars. The collective gravity of these closely packed stellar neighbors acted as a gentle brake on the rapidly escaping comets. This external gravitational influence lifted the closest approach points of the comet's orbits, pulling them safely away from the dangerous planetary zone. By circularizing and stabilizing their paths at immense distances, the birth cluster prevented these objects from falling back into the inner solar system. This ancient stellar brotherhood was essential in molding the chaotic spray of ice into the permanent, protective cocoon that exists today. The existence of this distant reservoir relies on a delicate balance of velocities that sits precisely at the edge of celestial stability. If the early planets had thrown these icy rocks with just a fraction more energy, the objects would have crossed the threshold of escape velocity and vanished into the galaxy. Conversely, if the push had been weaker, they would have remained trapped in the inner regions, eventually colliding with the planets or falling into the sun. The objects that populate the cloud today represent the ultimate survivors of this cosmic balancing act, possessing the exact energy required to inhabit the boundary zone. They exist in a state of permanent suspension, where their desire to fly out into the interstellar ocean is perfectly matched by the sun's patient, distant attraction. This precise equilibrium reveals that the outer frontier is not a chaotic accident, but a highly refined structure governed by the elegant laws of celestial mechanics. Modern astrophysics explains this massive cosmic clearing through advanced mathematical simulations known collectively as planetary migration models. These theories suggest that the giant planets did not form in their current positions, but instead engaged in a complex celestial dance, moving closer to and further from the sun over millions of years. This shifting of giant worlds acted like a colossal gravitational broom, sweeping the early solar system clean of its residual debris. Trillions of tons of primitive matter were displaced during this epic rearrangement, fundamentally reshaping the landscape of our stellar neighborhood. The creation of the comet sphere was the direct consequence of this planetary restructuring, serving as the cosmic dustbin where the excess materials were neatly stored. It shows us that the quiet serenity we observe today at the edge of space was purchased through an era of unimaginable planetary upheaval. When we calculate the sheer volume of matter involved in this ancient redistribution, we discover a story of immense cosmic waste and loss. Scientists estimate that the current population of the comet sphere represents only a tiny fraction, perhaps a few percent, of the original planetesimal disk. The vast majority of the early icy rocks, numbering in the hundreds of trillions, were completely ejected into the interstellar void during the chaotic scattering phase. Others were pulled inward, colliding with the young planets and bringing vital water and organic chemicals to the early Earth. The cloud we see today is merely the beautiful, leftover fragment of a much larger structure that was mostly lost to the wider galaxy. This reminds us that the universe often works through grand extravagance, creating vast structures through processes that scatter matter across the infinite dark. This dynamic history also suggests that the comet sanctuary may contain a fascinating mixture of materials gathered from different regions of the early solar system. Some models indicate that during the planetary migration, objects from the inner, rocky asteroid belt were scattered outward alongside the icy worlds of the outer disk. This means that hidden among the frozen mountains of water and methane are fragments of rocky, metallic matter born close to the sun's early heat. This unexpected diversity turns the outer sphere into a rich cosmic museum, preserving samples from every corner of the primordial solar nebula. It challenges the traditional view of comets as purely icy bodies, revealing a more complex and interwoven chemical narrative. The outer boundary stands as a unified archive, holding the complete material history of our stellar family's birth. While the immense gravity of Jupiter and Saturn played a major role in ejecting matter, it was actually Uranus and Neptune that served as the primary architects of the stable cloud. Because Uranus and Neptune are less massive than the inner gas giants, their gravitational kicks were more gentle and controlled. Instead of launching objects directly out of the solar system entirely, these ice giants nudged the planetesimals into orbits that extended precisely into the boundary zone. This allowed the external galactic forces and the sun's birth cluster to effectively catch the objects and stabilize them before they could escape. The subtle partnership between the ice giants and the wider galaxy highlights the intricate choreography required to build a permanent celestial structure. It positions Uranus and Neptune not as outer outcasts, but as the master craftsmen of our solar system's ultimate frontier. Ultimately, the comet sphere exists today as a perfect, frozen monument to the violent conclusion of our solar system's formative era. Once the giant planets settled into their current, stable orbits, the intense era of gravitational scattering came to a definitive end. The icy bodies that had been successfully pushed into the outer cloud were left in their current, slow orbits, far removed from any further planetary interference. They have remained there ever since, suspended in the deep freeze of absolute space, completely insulated from the subsequent history of the inner worlds. This absolute isolation means the cloud is a living snapshot of the exact moment our solar system achieved its structural maturity. As we contemplate this timeless sanctuary, we are looking at the final, quiet brushstrokes of the cosmic process that allowed our own planet to find peace and stability. The transition from a silent, drifting sentinel to an active visitor begins with a subtle loss of orbital energy. When a passing star or a galactic tide applies a gentle gravitational pull, it can slow down an icy body just enough to destabilize its trillion-mile-wide path. Deprived of the tiny amount of forward momentum that kept it suspended on the edge of the void, the object begins to yield to the patient gravity of the central sun. This marking point is completely invisible, an unprompted shift in direction that sets a massive frozen mountain on a path toward the light. It does not rush at first, but begins a long, falling descent that will last for hundreds of thousands of years before it ever encounters a planet. This quiet initiation shows how the most dramatic spectacles in our night sky are born from the quietest whispers of gravity at the edge of the world. As the icy traveler descends from the ultimate depths of the sphere, it enters a phase of gradual acceleration that spans cosmic distances. For millennia, it glides past the outer boundary markers, silently crossing the empty spaces where the gravity of our home star begins to grow stronger. As it approaches the realm of the giant planets, the silent vacuum gives way to a complex network of gravitational forces that can either accelerate its journey or alter its trajectory entirely. The traveler remains completely dark and frozen during this phase, a stealthy visitor passing through the deep shadows of Neptune and Uranus without changing its ancient appearance. Its speed increases steadily, transforming from a leisurely walk into a rapid cruise as the sun's pull becomes an undeniable command. This long journey toward the center is a magnificent display of kinetic potential, where a lifetime of cold stillness is slowly traded for motion and light. The turning point in the physical identity of the visitor occurs when it crosses a crucial boundary known as the solar system frost line. Located several hundred million miles from the sun, this invisible boundary marks the threshold where solar radiation becomes intense enough to warm the frozen surface. Before this moment, the extreme cold of deep space preserved the primitive compounds in their solid, icy matrix for billions of years. Now, the gentle warmth begins to penetrate the dark, insulating Tholin crust, reaching the volatile carbon and water ices hidden safely beneath. The solid matter experiences a sudden awakening, preparing to change its state without ever passing through a liquid form. This crossing is a magnificent chemical awakening, where the ancient ice of the outer cloud realizes it is no longer in the absolute dark of interstellar space. As the warmth of our home star increases, the process of direct sublimation begins to release the trapped gases into the vacuum of space. The solid ice transforms instantly into a glowing vapor, escaping through cracks in the dark crust and lifting fine grains of ancient dust along with it. This escaping material forms a massive, thin atmosphere around the frozen nucleus, a brilliant halo known to astronomers as the coma. This ghostly cloud of gas and dust can expand until it is hundreds of thousands of miles wide, making it significantly larger than the Earth itself, even though the rock at its center is only a few miles across. The coma acts as a glowing veil, reflecting the sunlight and announcing the presence of a visitor from the ultimate frontier to anyone watching from the inner planets. It is a beautiful transformation, where a hidden mountain of ice wraps itself in a grand robe of light and mist. As the expanding coma encounters the relentless torrent of energy flowing from the sun, it begins to develop its most famous and dramatic feature. The intense ultraviolet light from our star ionizes the escaping carbon monoxide and nitrogen gases, giving them an electrical charge that reacts strongly to the solar wind. This solar wind, a fast-moving stream of magnetic fields and charged particles, sweeps these light ions directly away from the sun at incredible speeds. The result is a perfectly straight, glowing blue ribbon known as the ion tail, which acts like a cosmic wind vane pointing directly into the dark. This tail does not follow the curve of the comet's path, but stands perpendicular to the sun, pushed back by the raw power of the solar breeze. Watching this blue streak reveals the invisible magnetic structures that connect our star to the arriving travelers from the outer cloud. Simultaneously, a second and distinct tail begins to form as the sunlight exerts a gentle physical pressure on the heavier grains of silicate dust. Unlike the light ions, these microscopic particles of stardust are too heavy to be swept instantly away by the solar wind, meaning they lag behind the comet's forward motion. They are pushed into a separate, gently curving path that reflects the orbital trajectory of the comet itself, creating a broad, brilliant white banner across the stars. This dust tail is lit by pure, reflected sunlight, making it highly visible to the naked eye from the surface of the Earth. It stands as a beautiful trail of ancient debris, a path of stellar ash scattered across the planetary plane like a long, luminous brushstroke. The coexistence of these two unique tails shows how a single icy visitor can interact with both the light and the matter of our star system. When a comet arrives from the spherical outer cloud for the very first time, it behaves differently from the periodic comets that have visited the sun many times before. This dynamically new traveler possesses an untouched surface, covered in highly volatile elements like carbon monoxide that flash into activity at much greater distances. Because it has never experienced the intense heat of the inner solar system, its first approach is often erratic, unpredictable, and brilliantly intense. Astronomers watch these pristine visitors with great anticipation, knowing they represent uncorrupted samples of the primordial solar nebula. As the sun vaporizes the outer layers, it exposes materials that have been kept in a dark freezer since the dawn of creation. This first encounter is a precious scientific gift, revealing the exact ingredients that built our planetary home before time began. As the visitor dives deeper into the inner solar system, it must navigate a dangerous obstacle course governed by the immense gravity of Jupiter. The largest planet in our family acts as a grand gatekeeper, capable of completely altering the destiny of any comet that crosses its path. If the arriving traveler passes too close to Jupiter, the planet's massive gravitational field can steal its orbital energy, trapping it in a short, tight loop close to the sun. This process permanently separates the comet from its ancestral home in the outer cloud, transforming it into a short-period visitor that returns every few decades. Alternatively, Jupiter can apply a powerful acceleration, launching the object completely out of the solar system into the interstellar void forever. This powerful intervention reminds us that the paths of these icy travelers are always subject to the heavy masters of the inner realm. A specific and dramatic group of these arriving icy mountains are directed on paths that bring them incredibly close to the actual surface of the sun. Known as sungrazers, these daring travelers plunge through the outer atmosphere of our star, experiencing temperatures of thousands of degrees. The intense gravitational and thermal stress is often too much for the fragile structure of ice and dust to endure, causing the comet to shatter into thousands of fragments. Some are completely vaporized during their closest approach, their ancient matter dissolving into the blinding light of the solar furnace. Others survive the fiery encounter, emerging from the sun's shadow with magnificent, hyper-bright tails that stretch across half the night sky. These extreme journeys show the ultimate contrast between the absolute zero of the Oort Cloud and the unimaginable fury of our parent star. For those comets that survive their brief rendezvous with the sun without being captured or destroyed, a long journey back to the outer darkness begins. As the object leaves the inner planets behind, the intensity of the sunlight drops, and the spectacular tails slowly fade back into the vacuum of space. The process of sublimation slows to a definitive halt, and the remaining nucleus wraps itself once again in its cold, dark crust of tholins. The traveler returns to a state of silent hibernation, carrying the physical scars of its fiery encounter back to the distant sphere. It will spend millions of years climbing back up the long gravity well, returning to the absolute peace of its icy family. This slow withdrawal completes the grand cycle of the comet's life, a beautiful transition from a brilliant guest of light back to a silent guardian of the edge. To fully comprehend the cosmic placement of this icy shell, we must recognize that it exists far beyond the protective magnetic bubble generated by our sun. This solar bubble, known as the heliosphere, shields the inner planets from the harsh, high-energy environment of the wider galaxy. But its boundary fades into insignificance long before the comet cloud begins. Our most distant robotic explorers have crossed this magnetic threshold into interstellar space. Yet they remain thousands of years away from even touching the inner gates of the comet's sanctuary. This means the trillions of sleeping ice mountains reside in the raw, unshielded wilderness of the Milky Way, completely exposed to the direct forces of the galactic medium. They exist in a fascinating state of duality, gravitationally bound to our parent star while physically immersed in the deep ocean of interstellar space. This exposure allowed the cloud to become a beautiful laboratory where the local galaxy interacts directly with the remnants of our solar cradle. The scientific world received its first tangible glimpse into the mysteries of the inner boundary through the discovery of an extraordinary reddish world named Sedna. This unique celestial body travels on a highly elongated path that never brings it close enough to be influenced by the gravity of Neptune, nor does it ever escape into the wider galaxy. Astronomers classify Sedna and a handful of similar worlds as detached objects, because their movements cannot be explained by interactions with the known planets. Instead, their paths serve as mathematical footprints, pointing directly to the hidden gravitational presence of the dense inner donut of the comet reservoir. By studying these lonely, distant lookouts, scientists are able to map the invisible architecture of the inner cloud without ever seeing the smaller comets directly. These worlds stand as silent sentinels, bridging the gap between the familiar icy worlds of the Kuiper Belt and the absolute infinity of the outer sphere. One of the most profound questions in astrophysics concerns the exact origin of the vast oceans that cover the surface of our vibrant Earth. And the answer may be locked within the ice of these distant travelers. By using advanced spectrometers to analyze the light of arriving comets, scientists measure a specific chemical signature known as the deuterium to hydrogen ratio, which acts as a unique cosmic fingerprint for water. This ratio determines the proportion of heavy water, which contains an extra neutron compared to the standard water that sustains terrestrial life. The measurements reveal a complex narrative, showing that while some Oort Cloud comets match the exact composition of Earth's oceans, others possess a distinct signature that indicates a different birth environment. This ongoing chemical investigation allows us to trace the ancient celestial rivers that may have delivered the gift of water to our young planet billions of years ago. It shows that every drop of water we enjoy today may have a deep, ancestral connection to the pristine ice drifting at the edge of space. The profound isolation and extreme cold of this outer boundary ensure that the material within the comets preserves the pristine isotopic ratios of the original solar nebula with absolute perfection. Unlike the inner planets, where geological activity, intense heat, and chemical processing have completely altered the primordial matter, the comet's sphere remains completely untouched by time. The atoms of carbon, nitrogen, and oxygen locked within the frozen methane and ammonia are arranged in the exact configurations that existed before the Earth was formed. This absolute preservation allows astrophysicists to read the chemical composition of the ancient gas cloud that collapsed to form our Sun 4,500,000,000 years ago. It is as if the universe created a perfect, frozen library at the edge of the solar system, keeping the original blueprint of our creation safe from the destructive forces of planetary evolution. As we contemplate these icy bodies, we are looking at the oldest, most uncorrupted matter in our celestial neighborhood. As our understanding of astrophysics expands beyond our local neighborhood, we discover that our Sun is not unique in possessing a magnificent shroud of sleeping comets. Observations of nearby stars through powerful infrared telescopes have revealed immense rings and spheres of cold dust that strongly resemble our own outer boundaries. Astronomers refer to these alien structures as Oort clouds, suggesting that the formation of an outer comet sanctuary is a natural and universal consequence of star birth. Every star that condenses from a galactic nebula likely undergoes a similar process of planetary migration, throwing its excess icy building blocks into the outer darkness. This means the galaxy is filled with trillions of invisible bubbles of ice, each wrapping a distant sun in a silent protective blanket of ancient matter. This universal perspective transforms our local sphere from an isolated anomaly into a beautiful, harmonious expression of standard cosmic architecture. A fascinating possibility arising from modern orbital simulations is that our comet sanctuary may not be entirely composed of native material born near our Sun. During the chaotic era of our Sun's birth, when it was still closely packed within a dense cluster of hundreds of sibling stars, the outer boundaries of these young systems frequently overlapped. In this crowded stellar nursery, the gravity of our young Sun could have easily intercepted and captured icy planetesimals that had been thrown out by neighboring stars. This means that a significant percentage of the comets sleeping in the outer sphere today might actually be alien visitors, born around entirely different suns across the ancient galaxy. These captured travelers would carry unique chemical signatures and histories, turning our outer frontier into a rich, international archive of interstellar matter. It is a beautiful thought that the edge of our solar system may be an ancient meeting place where the relics of forgotten stars rest together in absolute peace. The delicate behavior of the farthest icy bodies has led many astronomers to question whether a massive, undiscovered planet might be hiding in the deep shadows of the inner cloud. This hypothetical world, often referred to as Planet 9 or a distant ice giant, would possess enough mass to gently sculpt the paths of the surrounding comets through its patient gravity. Its presence would explain why certain distant objects travel on orbits that are strangely aligned and tilted in the same direction, as if guided by an invisible hand. If such a planet exists, it would move through the dense inner donut of the reservoir, acting as a dark king ruling over an empire of ice and silence. The search for this hidden planet requires analyzing the subtle distortions in comet movements, using gravity as a compass to navigate the uncharted darkness. This reminds us that the outer frontier may still hold massive surprises, challenging our complete map of the solar system's family tree. Some scientists have proposed a captivating theory that connects the slow movement of our solar system through the galaxy to periodic disruptions within the comet cloud. As the sun journeys around the galactic center, it gently oscillates up and down through the dense plane of the Milky Way disk every 30 million years or so. Passing through this crowded region increases the strength of the galactic tides and the likelihood of close encounters with interstellar gas clouds. This periodic increase in gravitational stress can trigger a massive wave of comets to descend toward the inner planets, potentially leading to increased cosmic impacts on Earth. While this theory remains a subject of intense scientific debate, it highlights the profound ways in which the largest structures of the galaxy can influence the history of life on our small world. It weaves a beautiful narrative where the slow, majestic dance of our star across the cosmos leaves its physical mark on the ancient rocks of our home. Even in the total absence of warm sunlight, the surfaces of these outer travelers undergo a slow and profound chemical evolution driven by the relentless energy of cosmic rays. This process, known to science as radiolysis, involves high-energy particles breaking the chemical bonds within the frozen water, methane, and ammonia ices. Over millions of winters, the freed atoms slowly recombine to form complex organic molecules, including amino acids and primitive sugars, without ever needing heat or liquid water. This means that the dark, velvety crusts of the comets are not just dead soot, but are actually rich storehouses of prebiotic chemistry synthesized in the absolute deep freeze of space. When these comets occasionally fall into the inner solar system and impact young planets, they deliver these ready-made organic ingredients directly to primordial oceans. The outer sphere thus acts as a quiet cosmic kitchen, slowly preparing the fundamental ingredients that can later spark the emergence of life under the warmth of a star. To complete our understanding of this grand structure, we must contemplate its ultimate destiny across the incomprehensible timescales of the far future. Over the next several billion years, our sun will eventually exhaust its nuclear fuel, expanding into a red giant before collapsing into a quiet, fading white dwarf. During this dramatic stellar evolution, the loss of the sun's mass will weaken its gravitational hold, causing the orbits of the remaining comets to expand even further into the galactic void. At these extreme distances, the collective pull of passing stars and galactic tides will easily strip away the outer layers of the sphere, scattering the icy fragments into interstellar space. The majestic cocoon that protected our solar system for eons will slowly dissolve, leaving its ancient travelers to wander the wider galaxy as lonely, independent nomads. This eventual fading reminds us that even the grandest structures of ice and gravity are temporary monuments, beautifully balanced for a season before returning their matter to the infinite cosmic ocean. Throughout the long history of human civilization, the sudden appearance of a brilliant comet in the night sky was often met with deep awe and existential dread. Ancient cultures viewed these winged visitors as celestial omens, cosmic messengers signaling the rise and fall of empires or the onset of great earthly transformations. Today, through the grounding lens of astrophysics, we understand that these spectacular apparitions are actually gentle reminders of our solar system's grand, frozen periphery. They are not chaotic disruptions of the cosmic order, but rather delicate messengers traveling from the ultimate boundary of our star's domain. When we watch a comet blaze across the velvet sky, we are witnessing a physical bridge connecting our immediate planetary home with the ancient, undisturbed silence of the outer sphere. This shift from fear to understanding highlights the beautiful journey of human curiosity, turning terrifying omens into treasured keys of our cosmic past. When astronomers plot the orbits of all known long-period comets, they discover a profound mathematical pattern that reveals the true location of this hidden reservoir. They notice a distinct grouping in the data, a sharp concentration of orbits that originate from a specific, immense distance across the void, which scientists refer to as the Oort peak. This statistical accumulation demonstrates that these icy travelers are not wandering randomly from interstellar space, but are breaking free from a well-defined, organized structure. The mathematical reciprocal of their orbital axes points directly to a shared ancestral home, proving the existence of the sphere through the elegant laws of probability and physics. It is a stunning realization that the invisible boundaries of our solar system can be mapped so precisely just by analyzing the geometry of falling ice. This peak stands as an intellectual monument, confirming that order reigns supreme even at the farthest, darkest edges of the sun's authority. Humanity has sent its most ambitious robotic messengers, the Voyager spacecraft, on an endless journey into the interstellar wilderness. Yet even these legendary explorers face an unimaginable trek before they reach this outer realm. Having crossed the magnetic boundary of the heliosphere, these silent metal travelers are currently drifting through the clean vacuum of space at tens of thousands of miles per hour. Despite this incredible speed, Voyager 1 will not reach the absolute inner boundary of the comet cloud for another 300 years, and it will require nearly 30,000 years to completely cross its vast, spherical expanse. By the time these dead machines drift past the outermost icy sentinels, the batteries that once powered their human voices will have been cold for millennia, turning them into silent phantoms among the sleeping ice. This vast timeline highlights the staggering scale of our local cosmos, revealing that our greatest technological achievements are merely tiny specks drifting through an ocean of deep time and space. To understand the physical nature of the trillions of objects sleeping in this distant sanctuary, we must reflect on the foundational insights of planetary science. In the middle of the 20th century, an American astronomer named Fred Whipple revolutionized our understanding by describing the core of a comet as a dirty snowball or an icy conglomerate. This elegant model suggests that the nucleus is a highly porous mixture of frozen gases and fine cosmic dust, bound together in a fragile, low-density structure. In the absolute zero environment of the outer shell, this delicate architecture is perfectly stabilized, preventing the volatile components from collapsing or disintegrating over billions of winters. The lack of external gravity or thermal energy allows these fluffy, cosmic dust bunnies to maintain their original shapes since the dawn of the solar nebula. This structural fragility reminds us that the greatest monuments of the outer frontier are built from the gentlest, most delicate arrangements of cosmic matter. When an inhabitant of the dark sphere finally approaches the inner solar system, it often wraps itself in a ghostly, luminous shroud of emerald green and deep cyan light. This beautiful coloration is not a reflection of the sun, but a vibrant chemical reaction caused by the intense solar radiation breaking apart organic molecules within the coma. The ultraviolet light tears into complex carbon chains, creating simple gases like diatomic carbon and cyanogen, which glow brilliantly when stimulated by the solar wind. This green signature stands out in stark contrast to the velvet blackness of space, serving as a visual declaration of the comet's ancient, organic heritage. While these objects spend eons cloaked in the darkest shades of charcoal and ash, their fiery awakening reveals a hidden palette of celestial colors. This spectacular transformation reminds us that the deep freeze of the outer boundary preserves a rich, hidden beauty that only awaits the light to be revealed. As a traveling mountain of ice rounds the sun, its movement is often influenced by subtle, unexpected forces that cannot be explained by gravity alone. The intense heat of our star causes localized pockets of volatile ice beneath the surface to vaporize violently, erupting through the dark Thalin crust in powerful, ghostly geysers. These escaping jets of gas and dust act like natural rocket engines, applying a gentle but continuous push that alters the comet's precise orbital trajectory. Astronomers refer to these variations as non-gravitational forces, which can unexpectedly advance or delay a comet's return to its ancestral home in the outer cloud. This dynamic jet effect introduces an element of beautiful unpredictability to the celestial mechanics of these wandering visitors, making their long-term paths difficult to predict with absolute certainty. It demonstrates that these icy travelers are not passive rocks, but active, breathing entities shaped by their internal chemistry. The journey through the inner solar system is fraught with extreme perils that can completely destroy the fragile architecture of an arriving comet. The intense thermal stress of transitioning from absolute zero to hundreds of degrees can cause deep fractures to tear through the porous, icy nucleus. Under the combined influence of this rapid heating and the powerful gravitational tides of the sun or giant planets, a comet will often split into several independent fragments. This celestial fragmentation creates a stunning train of smaller comets, each developing its own delicate tail as they drift along their shared orbital path. In some tragic encounters, the entire structure dissolves into a cloud of cosmic dust, vanishing entirely into the solar breeze without ever returning to the dark. This fragile destiny emphasizes the temporary nature of these icy visitors, showing that the journey into the light is often a beautiful but fatal pilgrimage for the children of the outer cloud. While the vast majority of the objects sleeping in this outer sanctuary are relatively modest in size, the deep darkness occasionally conceals true titans of ice and rock. Modern astronomical surveys have detected massive megacomets, such as the colossal Bernardinelli Bernstein, which possesses a nucleus measuring nearly 100 miles across. These giant worlds travel on immense paths that originate from the deepest, outermost layers of the sphere, requiring millions of years to complete a single circuit. As they slowly descend toward the inner realm, they blur the traditional line between comets and minor planets, challenging our understanding of cosmic classification. Scientists believe these titans represent a unique population of primordial objects that escaped the accretion process of the early gas giants entirely. Their rare appearance reminds us that the distant frontier is not just a collection of tiny fragments, but a grand kingdom capable of hosting massive, independent worlds. At the ultimate outer limits of this magnificent sphere, the physical concept of escape velocity drops to a value that is astonishingly small. Because the gravitational pull of our central sun is reduced to a faint, distant whisper, an object requires only a tiny fraction of energy to break its bonds completely. A movement as gentle as a human walking or a stone being thrown would provide enough velocity to launch an icy fragment out of the solar system forever. This precarious state means the outer boundary is an incredibly sensitive cosmic shoreline, where the slightest ripples from the wider galaxy can alter the destiny of trillions of worlds. the objects exist in a state of perpetual weightlessness, barely anchored to their parent star while floating on the edge of the infinite interstellar ocean. This extreme fragility illustrates how gracefully our solar system concludes, ending not with a heavy wall of force, but with a soft, delicate pause in the dark. When we look at the grand architecture of our stellar system as a unified whole, we realize that this vast sphere of ice serves as a protective buffer zone against the external galaxy. This immense bubble of darkness absorbs the faint gravitational shocks, passing stars and drifting dust of interstellar space, dampening their impact before they can disturb the inner planets. It acts as a soft, elastic shield, filtering the cosmic environment and preserving the long-term stability of the planetary home where life was allowed to flourish. Trillions of quiet, frozen sentinels stand watch at the gates of our world, occupying a space so wide that it isolates our sun from the chaotic wilderness of the Milky Way. By understanding this protective layout, we see that our own existence is intimately connected to the silent, patient presence of this outer comet sanctuary. We can rest in the knowledge that our planetary family is wrapped in a grand, timeless cocoon of ice, floating securely within the deep ocean of the universe. When we observe a comet passing through the inner solar system, we are witnessing an object with a highly limited operational lifetime. Each time one of these icy travelers rounds the sun, the intense heat vaporizes millions of tons of its ancient volatile material, slowly stripping away its protective layers. After just a few hundred or thousands of passes, a comet will either completely disintegrate into a trail of dust or become a dead, inactive rock incapable of producing a glowing tail. Yet, despite this continuous destruction of individual visitors, the grand outer reservoir remains fully populated and structurally stable across billions of years. This enduring stability is maintained by an incredibly slow, majestic pipeline of replacement, where the outer shell holds trillions of undisturbed objects waiting for their rare turn to descend. It is a profound cosmic balance where the rapid, fiery death of a few visible travelers highlights the permanent, silent preservation of the infinite majority sleeping in the dark. The true spatial extent of this magnificent comet sanctuary is mathematically defined by a concept known to astrophysicists as the Hill sphere of our Sun. This immense theoretical bubble outlines the exact volume of space where our parent star's gravitational pull is stronger than the tidal forces of the surrounding Milky Way galaxy. The outer edges of the comet cloud sit precisely at the threshold of this gravitational boundary, marking the absolute limit of our solar system's structural integrity. Beyond this delicate perimeter, the gravity of the collective galaxy takes complete control, making it impossible for our sun to permanently hold onto any drifting matter. The cloud is therefore the physical manifestation of the sun's reach, a colossal spherical monument tracing the precise zone where our star's authority fades into the grand galactic ocean. It reveals that our home is not a shoreless expanse, but a beautifully bounded island of gravity suspended within a wider stellar wilderness. Throughout the long evolution of the inner planets, the objects arriving from this distant sphere have acted as unpredictable wild cards in the history of planetary impacts. Unlike the asteroids or short-period comets, which travel on predictable tracks within the flat planetary plane, these long-period visitors can descend suddenly from any direction in the three-dimensional sky. Because they fall from such an unimaginable height at the very edge of the solar system, they gather an immense amount of gravitational speed during their long descent. When one of these massive icy mountains intersects the path of a planet, it carries far more destructive kinetic energy than a typical asteroid of the same size. These rare but high-energy events have left massive scars on the surfaces of the Moon and the planets, driving major geological and biological transformations across cosmic epochs. They remind us that the quiet, frozen periphery is always connected to the vibrant history of the inner worlds, occasionally reshaping the landscape of life through the raw mechanics of motion. When we look closely at the internal physics of these wandering ice mountains, we discover that they possess absolutely no intrinsic magnetic fields. Unlike the large planets which generate powerful magnetic shields through the movement of molten metals deep within their cores, these primitive objects are completely cold and structurally simple. They drift through the dark void as magnetically transparent entities, allowing the sweeping magnetic currents of the wider galaxy to pass through them without any resistance or interaction. This lack of magnetic identity means they cannot trap solar particles or create their own auroras, remaining entirely silent to the electromagnetic instruments used by modern science. The only charges they carry are the faint, frozen residues of the primordial dust cloud from which they originally condensed billions of years ago. This absolute magnetic stillness reinforces their identity as passive, uncorrupted remnants of creation, floating through the celestial currents like quiet ghosts of ice. To study these hidden worlds without the benefit of direct vision, modern astronomers must rely on advanced instruments that look beyond the narrow spectrum of visible light. By utilizing massive space telescopes that operate in the submillimeter and infrared wavelengths, scientists can detect the faint thermal glow of dust grains just as a comet begins to wake up in the deep freeze. These invisible frequencies of light allow us to analyze the chemical composition of the escaping gases long before the object becomes bright enough to be seen by the human eye. Each element, from frozen carbon to primitive silicates, leaves a unique mathematical signature across the infrared spectrum, acting as a chemical fingerprint that travels across the void. This sophisticated method of observation transforms the dark, silent vacuum into a rich map of data, allowing human minds to decode the secrets of the outer cloud from the comfort of our warm planet. It proves that the universe can be fully understood not just by looking at what is bright, but by carefully listening to the cold, invisible whispers of matter. The trajectories of the trillions of objects sleeping in this outer shell are not permanently fixed in stone. Instead, they undergo a slow and continuous process called orbital diffusion. Over the course of hundreds of millions of years, the microscopic gravitational pull of every star in our galactic neighborhood gently nudges the paths of these distant icy mountains. This constant, random interaction causes the orbits to slowly drift or walk through a complex mathematical space, shifting their orientation and shape over vast geological epochs. An object that once traveled on a perfectly safe path at the outer edge may, over eons, find its orbit slowly elongated until it is pulled toward the inner solar system. This slow, chaotic evolution turns the comet cloud into a living, shifting structure that is constantly changing its internal configuration in response to the wider galaxy. It demonstrates that even in a realm where time seems to stand completely still, the laws of physics are always gently reshaping the landscape of the dark. One of the most comforting and profound characteristics of this outer frontier is the absolute, unbreakable acoustic silence that defines its entire volume. Because the density of matter within this immense sphere is so unbelievably low, there is no atmosphere or physical medium capable of conducting sound waves across the void. If a giant mountain of ice were to fracture, collide with a smaller fragment, or erupt with powerful gas geysers, the event would transpire in total and absolute silence. There are no echoes, no whispers, and no soundscapes out here. There is only the quiet, visual choreography of drifting frost cast against the black canvas of space. This absolute absence of sound creates a realm of supreme tranquility, where the violent energies of cosmic creation are tamed into a silent, slow-motion dance. It allows the mind to visualize a place of perfect rest, where the frantic noise of our daily existence is completely swallowed by the infinite stillness of the interstellar vacuum. Locked deep within the amorphous ice cages of these pristine comets is a collection of highly volatile elements known to chemistry as the noble gases. Substances like helium, neon, argon, krypton, and xenon require temperatures near absolute zero to be trapped and held within a solid matrix without escaping into space. Because the outer sphere has maintained a constant temperature of 3 Kelvin since its formation, it has preserved these elusive gases in their exact primordial proportions. Scientists view these trapped elements as cosmic tracers because they do not easily react with other matter, leaving their ancient signatures completely uncorrupted by time. Analyzing these noble gases provides astronomers with a precise thermometer of the early universe, revealing the exact temperature of the molecular cloud before our sun first ignited. They serve as a beautiful testament to the preserving power of the outer deep, keeping the most delicate gases safe for billions of winters. When an icy traveler finally breaks free from its long suspension, and descends toward our star. Its arrival is defined by an extraordinary amount of kinetic energy. Because the comet is falling from a height of tens of thousands of astronomical units, it accelerates continuously for hundreds of thousands of years along its path. By the time it crosses the orbit of the Earth, its speed relative to the Sun can exceed 100,000 miles per hour, which is vastly faster than the planets themselves move. This extreme velocity gives long-period comets a magnificent, dynamic presence, allowing them to rush through our skies in a matter of weeks before vanishing back into the dark. It also means that their motion is highly resistant to minor gravitational disruptions, carving straight through the planetary plane like cosmic arrows of ice. This breathtaking speed is the direct consequence of their immense journey, a beautiful expression of potential energy accumulated over millions of years of quiet drifting. As we reach the outermost limits of this magnificent structure, we realize that the cloud does not end with a sharp boundary or a defined wall of matter. Instead, it experiences a gradual, poetic thinning out, a cosmic twilight zone where the density of icy fragments slowly fades into the absolute vacuum of interstellar space. The distance between individual comets increases from hundreds of millions of miles to multiple light years, until the concept of a unified solar system completely dissolves. In this ultimate transition zone, the gravity of our sun becomes a completely indistinguishable whisper, fully blending with the collective pull of the surrounding stars. A traveler passing through this region would never know the exact moment they left our stellar home behind, entering the vast, uncharted ocean of the wider galaxy. This graceful conclusion highlights the seamless nature of the universe, where even the grandest structures conclude not with a violent end, but with a soft, beautiful fading into the infinite dark. As our solar system completes its grand orbit around the galactic center, it periodically passes through the dense, tightly packed spiral arms of the Milky Way. These galactic structures are heavily populated with massive stars and immense dust clouds, creating a localized surge in gravitational activity. When our star enters these vibrant cosmic highways, the increased frequency of nearby stellar passages gently ripples through the outer comet sanctuary. This extra gravitational kneading can trigger a prolonged increase in the number of icy bodies nudged toward the inner planets, shaping the long-term rhythm of comet activity on Earth. It shows how the majestic, swirling anatomy of our entire galaxy directly regulates the quiet movements of the frozen fragments sleeping at our system's edge. When we look at the internal distribution of matter within this massive bubble, we find a profound structural gradient that defines its density. The inner core, known as the Oort Cloud, holds a dense and closely packed population of icy mountains that represents the true heart of the reservoir. As we move outward into the vast open spaces of the spherical shell, the distance between these frozen worlds increases dramatically, causing the cloud to grow exponentially thinner. In these outer reaches, a single comet may drift for light years without ever coming near another fragment of primitive ice. This gradual transition from a relatively dense inner ring to a whisper-thin outer boundary illustrates the beautiful, fading structure of our solar system's architecture. When a long-period comet completes its rare journey through the inner solar system, it leaves behind a long, invisible highway of microscopic dust particles shed from its glowing tail. This ancient debris remains suspended in space, tracing the exact orbital path of the departed icy traveler for centuries after it returns to the dark. When our Earth occasionally passes through one of these forgotten cosmic trails, these tiny specks of stardust collide with our atmosphere, creating spectacular meteor showers that illuminate the night sky. Each shooting star we witness during these events is a physical piece of the outer frontier, a tiny fragment of pristine dust that slept for billions of winters in the absolute cold. This beautiful interaction allows us to touch the matter of the farthest boundary without ever leaving the comfort of our home world. The pristine environment of the outer shell is constantly interacting with the faint, flowing winds of the local interstellar medium. This cosmic wind consists of sparse hydrogen and helium gases, along with microscopic grains of interstellar dust that drift between the stars of our galactic neighborhood. As our solar system moves through this thin material, the outer comets experience a microscopic, continuous drag force over billions of years. Though this interaction is incredibly subtle, it slowly shapes the outermost orbits, influencing how tightly the sun can hold onto its most distant children. It reveals that the vacuum of space is never truly empty, but is instead a gentle fluid that whispers against the frozen sentinels of our outer boundary. Deep within the uncorrupted ice cages of these wandering mountains lies a unique collection of volatile sulfur compounds that offer profound clues about our chemical ancestry. Elements such as hydrogen sulfide and carbon disulfide are perfectly preserved within the frozen matrix, remaining completely unaltered since the collapse of the primordial nebula. Because sulfur chemistry is highly sensitive to temperature changes and radiation, its preservation proves that these objects have never left the deep freeze of the outer cloud. Analyzing these pristine sulfur molecules allows astrophysicists to reconstruct the exact chemical conditions that existed before the formation of the first solid planets. It transforms each dark fragment of ice into a precious laboratory, safely guarding the chemical secrets of our solar system's earliest moments. The perfectly spherical shape of the outer cloud represents the beautiful conclusion of a process known to astronomers as orbital randomization. When the early planets first hurled these icy rocks into the outer dark, the objects still remembered the flat orientation of the planetary disk. However, over billions of winters, the continuous, gentle kneading of galactic tides, and passing stars completely erased this structural memory. The paths of the comets were slowly tilted, twisted, and scattered into every possible direction, transforming a flat ring into a magnificent three-dimensional bubble. This complete loss of original orientation shows how the wider galaxy patiently overwrites the local geometry of our star system, sculpting a monument of perfect symmetry from chaotic beginnings. Because sending a robotic explorer to the actual boundaries of the cloud requires thousands of years, modern space agencies are designing ingenious methods to study this realm from afar. Scientists are preparing advanced robotic spacecraft designed to sit patiently in space, waiting for a pristine, dynamically new comet to begin its very first descent from the outer sphere. Once an arriving traveler is detected, the interceptor spacecraft will alter its course to fly incredibly close to the pristine mountain of ice, capturing high-resolution data and analyzing its fresh coma. This clever approach allows humanity to study the untouched matter of the outer boundary without needing to cross the immense gulf of space that separates us from it. It represents a beautiful triumph of human ingenuity, turning the arrival of a cosmic guest into a direct window into the ultimate frontier. While the outer spherical shell of the cloud is constantly losing its inhabitants to the wider galaxy or the inner solar system, the dense inner core remains a permanent, unbreakable vault. This inner ring is situated close enough to the sun to be fully shielded from the disruptive stripping forces of passing stars and galactic tides. It acts as a deep, secure reservoir that preserves its massive population of icy planetesimals with absolute fidelity across cosmic epochs. Even when the outer layers of our solar system are slowly eroded by the changing environment of the Milky Way, this inner core ensures that the primordial heritage of our system remains intact. It stands as an enduring foundation of matter, a silent heart that guarantees the continuity of our comet sanctuary through the eons. The delicate movements of the farthest icy sentinels may also be influenced by the invisible presence of dark matter distributed throughout the galactic disk. Astrophysics suggests that this mysterious, unseeable substance exerts a subtle but collective gravitational pull that adds to the strength of the standard galactic tides. As our solar system glides through the dark matter web of the Milky Way, the outer edges of the comet sphere experience a gentle, continuous compression. This exotic interaction means that the orbits of our most distant comets are shaped not just by the visible stars, but by the hidden scaffolding of the entire universe. It connects our local frontier to one of the greatest mysteries of modern science, showing how the invisible forces of the cosmos leave their mark on the ice. Ultimately, this magnificent sphere of sleeping comets represents the true horizon of our local cosmic knowledge, the final boundary before we look out toward other star systems. It defines the maximum extent of what we can call our home, a colossal bubble of dark potential that contains everything born from our ancestral cloud of gas and dust. Beyond its fading outer edges lies the true wilderness of interstellar space, an ocean of darkness that stretches for light years before reaching the family of another star. By anchoring our minds in this immense structure, we gain a profound appreciation for the true scale of our isolation and our placement within the cosmos. It stands as a beautiful, silent testament to the grandeur of our home star, wrapping our planetary family in an eternal shroud of pristine ice and absolute peace. The majestic boundary of our solar system is not a closed fortress, but an open harbor that occasionally plays host to travelers born under alien suns. In recent years, our telescopes have detected mysterious interstellar objects rushing through the interplanetary plane, arriving from the deep wilderness of the galaxy. Long before these foreign rocks ever encountered our familiar planets, they had to silently navigate the vast, sparse architecture of our outer comet sphere. This reality implies that a continuous, quiet exchange occurs at the ultimate frontier, where our native comets brush past interstellar nomads in the dark. It paints a picture of a deeply connected universe, where the boundaries between star systems are beautifully fluid and welcoming. By observing these rare encounters, we realize that the dark cocoon surrounding us is a porous shoreline, softly interacting with the currents of the grand galactic ocean. In the absolute absence of a bright, warming sun, the surface composition of these distant worlds is subtly modified by the cold light of distant stars. This ambient illumination, known to astrophysicists as the interstellar radiation field, bathes the outer shell in a permanent, gentle starlight that never ceases. While this faint energy is far too weak to melt the ancient water ice, it provides just enough photons to trigger slow, delicate alterations in the surface polymers. Over millions of winters, the collective glow of the entire Milky Way acts as a patient cosmic artist, tinting the charcoal crusts with unique molecular variations. This starlight chemistry reveals that even at the most isolated edge of our system, matter remains responsive to the wider galactic community. It is a beautiful testament to the interconnected nature of space, where the light of forgotten suns helps shape the frozen sentinels of our own home. To truly appreciate the serenity of this outer kingdom, we must contemplate the incredible physical vacuum that exists between its trillions of frozen inhabitants. If we were to collect all the matter scattered across this immense, three-dimensional bubble, it would represent a density far lower than the cleanest laboratory vacuums achievable on Earth. The vastness of the empty space is so overwhelming that the cloud is defined not by the presence of ice, but by the magnificent abundance of pure, uncluttered nothingness. A traveler could journey for thousands of years through this domain without ever encountering a single grain of dust or a microscopic crystal of frost. This absolute spaciousness brings a profound sense of cosmic order, where every solitary comet is granted an immense kingdom of silence to call its own. It reminds us that the universe builds its grandest structures not with heavy walls, but with the delicate, unburdened freedom of the void. The quiet stability of the outer sphere is occasionally tested by the stealthy passage of cosmic phantoms known as brown dwarfs and rogue planets. These failed stars and homeless worlds drift independently through the galactic darkness, lacking any companion suns to illuminate their cold journeys. When such a massive, hidden entity glides past the outer boundary of our system, its heavy gravity acts as a silent broom, reshaping the paths of thousands of sleeping comets. These encounters happen in total darkness, an invisible dance of mass and gravity that leaves permanent ripples across the architecture of the outer shell. Astronomers study the subtle irregularities in modern comet orbits to detect the historical footprints of these passing dark giants. This research reveals that the outer frontier is a dynamic crossroads, constantly whispering with the hidden, wandering weights of the wider galaxy. When we search for the true, definitive edge of our solar system, we must look past the magnetic thresholds discovered by our robotic probes and embrace the realm of pure gravity. While the magnetic influence of the solar wind fades relatively close to the planets, the gravitational authority of our sun extends thousands of times further into the dark. The Oort Cloud is the ultimate expression of this gravitational dominion, tracing the absolute limit where our star can still claim matter as its own. It is the true physical border of our celestial home, an immense sphere that contains everything bound to our ancestral cradle. Understanding this distinction allows us to appreciate the true grandeur of our star's reach, which extends far beyond the familiar planetary disk. The comet sphere stands as the final, majestic wall of our stellar house, separating our local family from the deep, uncharted wilderness of interstellar space. Because these distant mountains of frost reflect no sunlight and emit no internal warmth, human ingenuity has devised brilliant, indirect methods to map their hidden positions. Astronomers are developing advanced space missions that utilize a technique known as stellar occultation to detect these invisible travelers against the background of space. By pointing highly sensitive cameras at dense fields of distant stars, scientists wait for a hidden comet to briefly pass in front of a stellar light source. For a fraction of a second, the distant star will seem to blink or fade, revealing the precise size, speed, and distance of the intervening icy body. This elegant method transforms the entire galaxy into a brilliant backlight, illuminating the dark architecture of our outer boundary through the simple mechanics of shadows. It proves that the most hidden realities of the cosmos can be uncovered if we learn to watch the lights of the universe with enough patience and precision. The ancient ice drifting at the edge of space may play a profound role in a grand cosmic hypothesis known to science as panspermia. This theory suggests that the fundamental seeds of life are not confined to individual planets, but are continuously transported across the galaxy inside the protective cores of comets. Because the outer shell is constantly shedding its icy inhabitants into interstellar space due to galactic tides, our sun has been scattering trillions of time capsules across the Milky Way for billions of years. These escaping fragments carry pristine organic molecules and complex chemical compounds synthesized in the deep freeze, ready to be delivered to young planetary systems around neighboring stars. Simultaneously, our system may have captured similar icy messengers thrown out by alien suns, creating a beautiful galactic network of biological potential. This perspective transforms the outer cloud from a lonely graveyard of ice into a grand interstellar post office, silently distributing the raw materials of life across the stars. Humanity's desire to touch this pristine frontier has inspired the creation of revolutionary space missions designed to intercept these ancient travelers at the very beginning of their descent. Modern space agencies are building sophisticated robotic spacecraft that will sit quietly in a stable orbit near Earth, waiting for a dynamically new comet to be discovered. Once a pristine visitor from the outer sphere is detected entering the inner solar system, the interceptor will ignite its engines to perform a rapid, precise rendezvous. This automated explorer will fly through the fresh, glowing coma, capturing pristine samples of gas and dust that have been frozen since the dawn of creation. This clever strategy allows us to study the untouched matter of the outer boundary without needing to survive a thousands of years journey into the deep dark. It represents a beautiful bridge between human curiosity and the ultimate frontier, bringing the secrets of the outer shell directly to our doorstep. As we contemplate the immense lifespan of this cosmic sphere, we discover a striking contrast between the fragility of the inner planets and the permanence of the outer ice. While the rocky worlds close to the sun are constantly reshaped by volcanoes, oceans, and eventual solar expansion, the distant comet sanctuary remains locked in a state of unchanging preservation. When our sun eventually enters the twilight of its life billions of years from now, it will expand into a red giant, completely consuming the inner planets and leaving the Earth as a charred, lifeless rock. Yet, during this cataclysmic transformation, the dense inner core of the comet reservoir will remain largely unaffected, safely insulated by the massive gulf of space. The cloud will survive the death of the planetary system, preserving the original chemical signature of our birth, nebula long after the worlds of gas and rock have vanished. This incredible endurance turns the outer sphere into the ultimate monument of our solar system, a permanent archive that will outlast time itself. At the ultimate boundary of this magnificent shell, the concept of a local solar system finally achieves its complete and beautiful resolution. We have journeyed from the warm, vibrant heart of our planetary family through the icy rings of the Kuiper belt to the absolute edge of our star's physical reach. Here, surrounded by the last, loneliest sentinels of pristine ice, we look out into the infinite expanse of the interstellar ocean that stretches toward the distant stars. The pull of our sun is now a complete whisper, a fragile gravitational thread that is perfectly balanced by the grand, breathing rhythm of the collective galaxy. We stand on the definitive shoreline of our cosmic home, a place of supreme tranquility where the familiar ends and the eternal begins. Let your mind rest in this magnificent, all-encompassing sphere of silence, wrapped in the protective cocoon of ice that has guarded our world since the beginning of days. Our long, drifting journey through the outermost frontier of our solar system now draws to a quiet, natural conclusion. We have traced the incredible architecture of this sphere of ice, moving far past the known planets and the flat pathways of our local worlds into a truly three-dimensional kingdom of absolute serenity. From the dense inner donut of the hills cloud to the whisper-thin outer shell that stretches halfway to the nearest stars, this grand structure stands as a beautiful monument to cosmic preservation. Trillions of primitive worlds sleep out here in the deep freeze of absolute space, completely untouched by the frantic passages of time that reshape our warm Earth. They hold the uncorrupted material of our cosmic birth nebula, acting as a permanent library that preserves the ancient history of our stellar home with absolute perfection. These frozen mountains of water, methane, and ammonia drift in absolute acoustic silence, devoid of any internal magnetic fields, floating like quiet phantoms of frost in the dark hall. As we linger at this majestic, silent shoreline, we realize how gracefully our solar system blends into the grand, interconnected tapestry of the wider Milky Way galaxy. The delicate orbits of these distant comets, balanced on a tightrope between the fading pull of our sun and the gentle tides of the galaxy, remind us that nothing in the cosmos exists in true isolation. Every passing star, every drifting interstellar cloud, and even the invisible scaffolding of dark matter leaves a soft, permanent ripple across this ocean of darkness. It is a realm defined not by crowded chaos, but by a beautiful abundance of pure, uncluttered spaciousness, where every lonely traveler is granted an immense kingdom of silence to call its own. The spectacular comets that occasionally visit our skies, wrapping themselves in robes of emerald light and long glowing banners of dust, always return to this deep sanctuary, trading their brief moment of light for a lifetime of slow, peaceful drifting. Now, the frantic noise of our daily existence completely dissolves into the infinite, acoustic silence of the interstellar vacuum. We leave the children of the outer cloud to continue their slow, majestic dance across the eons, drifting securely within their grand protective cocoon of ancient ice. The sun ahead has faded into a solitary, brilliant star. Its gravitational thread holding our planetary family safe within a vast, beautiful bubble of dark potential that will outlast time itself. As the rhythm of our cosmic exploration slows to a definitive halt, the mind finds its own perfect equilibrium, fully aligned with the patient, timeless cycles of the cosmos. Let yourself rest securely in the knowledge that we are wrapped in a magnificent, enduring sanctuary of peace that has guarded our world since the beginning of days. Sleep peacefully under the silent, watchful gaze of the infinite universe.